We are at the beginning of a new era, a moment in history that future generations will look back upon as the start of the second industrial revolution. In the first industrial revolution, we learned how to harness steam and water to automate physical labor, expanding the reach of the human muscle. Today, we are learning how to harness accelerated computing to automate intelligence, expanding the reach of the human mind. This is our iPhone moment for artificial intelligence, but it is much larger than a single device. It is a fundamental shift in the very fabric of how we solve problems. For the last 60 years, we have lived in the era of general-purpose computing, where we wrote software to run on CPUs. That era is over. We have reached the limits of what traditional scaling can achieve. We are now entering the age of the AI factory, where data goes in and intelligence comes out. Lately, I have been hearing a lot of noise about what people are calling the 600-watt problem. Critics and observers look at the power requirements of our latest architectures, the Blackwells and the high-end 50 series designs, and they ask a simple, pointed question. Jensen, did NVIDIA go too far? Have you pushed the power envelope beyond the point of reason? It is a fair question, but it is a question asked through the lens of the old world. To understand why we are doing what we are doing, you have to step away from the surface-level numbers and look at the first principles of computation. You have to ask not, how much power does this chip use, but rather, how much intelligence does this power produce? When you look at a 600-watt thermal design, you are looking at the result of an impossible engineering challenge. We didn't choose that number because we wanted to be inefficient. We chose it because the alternative is much, much worse. For decades, the industry relied on Moore's law to give us a free lunch. We expected transistors to get smaller and more efficient every 2 years, allowing us to stay within the same power envelopes while gaining performance. But Moore's law has ended. The physics of the subatomic level have become an adversary. If we had stayed on the path of general-purpose computing, relying on CPUs to do the heavy lifting of AI, the power requirements for the world's data centers wouldn't be measured in watts. They would be measured in percentages of the global energy grid. We would be building power plants just to keep up with the demand for basic search queries. Accelerated computing is the only way out of this energy trap. By creating a specialized engine that is 10,000 times faster at certain tasks than a CPU, we are actually saving a massive amount of energy at the system level. A single Blackwell GPU doing the work of 1,000 CPUs uses significantly less power than those 1,000 CPUs combined. So, when people ask if we went too far with a 600-watt chip, I tell them we didn't go too far. We went as far as we had to so that the rest of the world could use less. We are trading power density for total system efficiency. We are concentrating the work so that the world can move faster and cleaner. This journey of pushing the limits has always been the story of NVIDIA. We are a company that has been 30 days from bankruptcy for 30 years. We have always lived on the edge of the impossible. I remember back in the mid-90s when we were working on the Riva 128. We had already failed once with our first chip. We were running out of money. We had to decide, do we play it safe and build something that fits into the existing market, or do we take a massive risk and build something that defines the future? We chose the risk. We chose the hard path. We had to be humble enough to admit our previous mistakes, but resilient enough to double down on our vision of 3D graphics. That resilience, that willingness to face the pain and suffering of invention is what allows us to tackle the 600-watt problem today. If you want to do something that has never been done, you have to be willing to solve problems that no one else wants to touch. Thermal management at this scale is an impossible problem. To dissipate 600 watts of heat from a piece of silicon the size of a postage stamp is a miracle of materials science and mechanical engineering. Our teams had to reinvent liquid cooling, heat pipe technology, and power delivery systems from the ground up. We didn't do it because it was easy. We did it because the work of your life should be to build things that didn't exist before. If you aren't pushing the boundaries of what is physically possible, you aren't really innovating. You're just iterating. At NVIDIA, we maintain a very flat structure. I don't sit in a corner office and wait for reports to trickle up through 10 layers of management. I want to be in the room with the engineers who are arguing about the thermal conductivity of a new interface material. I want to know why a specific power stage is failing. We don't have a hierarchy of status. We have a hierarchy of ideas. This allows us to move with incredible speed. In this new industrial revolution, the pace of change is so high that if you stop to coordinate your movements through a traditional corporate structure, you are already dead. You have to run, don't walk. You have to move at the speed of light because that is the speed at which the future is arriving. The 600W problem isn't a bug, it's a feature of the new reality. We are no longer building components, we are building supercomputers that happen to fit into a slot. We are building the engines of the next era of human civilization. If you want to train a model that can understand the structure of a protein or predict the path of a hurricane, you need compute density. You cannot solve these problems with 65-watt parts. You need the intensity, you need the heat, you need the power, but you also need the wisdom to use that power effectively. I often tell students that I wish them great doses of pain and suffering. I say that because character is not built in times of comfort. Character is built when you are staring at a design that is overheating, when your software stack is crashing, and when the industry is telling you that your vision is flawed. We have suffered through the skepticism of ray tracing. We suffered through the early years of CUDA when no one understood why we were building a parallel computing platform. But we stayed the course because we followed first principles. We knew that the world would eventually need this level of performance. We knew that the CPU would eventually run out of steam. Today, the world has caught up to our vision. Every company is now an AI company. Every country is looking to build its own sovereign AI. And they are looking to us to provide the engines. When we designed the 50 series, we didn't just look at the benchmarks for current games. We looked at the requirements for the next generation of physical AI. We looked at what it would take to run a digital twin of a factory or to simulate the sensor suite of an autonomous vehicle in real time. That requires a level of performance that forces us to push the limits of power. But here is the truth that often gets lost in the conversation. The cost of compute is not the price of the chip or the wattage of the power supply. The cost of compute is the time it takes to reach an answer. If a 600-watt chip can give you the answer to a life-saving medical question in a day, while a lower power chip takes a month, which one is actually expensive? Which one is wasteful? In the age of AI, time is the only truly finite resource. We are building machines that buy us time. We are building machines that allow us to compress decades of research into weeks. We didn't go too far. In fact, we are just getting started. The appetite for intelligence is infinite. As we find more ways to apply AI to the physical world, to robotics, to climate science, to energy production, the demand for dense, high-performance compute will only grow. Our job is to make sure that we are delivering that compute in the most efficient way possible, even if that means rethinking everything we thought we knew about hardware design. This is why I don't have a traditional office. I want to be where the friction is. Friction is where the heat is, but it's also where the progress happens. You cannot have innovation without friction. You cannot have a breakthrough without the pressure of a deadline or the threat of failure. We embrace that pressure. We welcome the 600-watt problem because it is a signal that we are working on the right things. It is a signal that we are at the very frontier of what is possible. I want you to think about the transition we are in. For 60 years, we were in the era of retrieval. You asked the computer for a file, and it found it. You asked the computer for a web page, and it retrieved it. We are now in the era of generation. You ask the computer for a solution and it generates it. It doesn't find it, it thinks it through. This transition requires a fundamental re-architecting of the computer. It requires a move from the serial to the parallel, from the general to the accelerated. This is the work of our lives. We are building the foundation for a future where every object is intelligent, where every process is optimized, and where the human imagination is the only limit. To get there, we have to be willing to break things. We have to be willing to challenge the status quo. We have to be willing to build things that are so powerful they make people uncomfortable, because comfort is the enemy of progress. When people see NVIDIA, they see the market cap and the headlines. But I want you to see the busboy from Denny's. I want you to see the company that was 30 days from bankruptcy. I want you to see the engineers who spent 5 years working on a single cooling breakthrough. That is the heart of NVIDIA. We are a company of survivors. We are a company of learners. We don't believe in our own expertise. We believe in our ability to learn the next thing, to solve the next impossible problem, and to run toward the future with everything we have. The 600-watt problem is just another wall for us to climb. It is another opportunity to reinvent ourselves. And as we climb it, we are bringing the rest of the world with us. We are making sure that the tools of the next industrial revolution are available to everyone, from the largest data center to the enthusiast gamer. because the revolution won't be won by a few large corporations. It will be won by the millions of creators and engineers who use this power to build something incredible. Incredible things happen when you give people the tools to simulate reality before they build it. You see, the 600-watt design isn't just about pushing electrons, it's about increasing the density of thought. In the old world of computing, if you wanted more performance, you just added more servers. But there is a hidden cost to that, the cost of communication. When you have 10 different chips trying to talk to each other to solve one problem, they spend more energy talking than they do thinking. By concentrating that power into a single high-density Blackwell or 50 series module, we are collapsing the distance between the data and the logic. We are making the brain more compact. And in the world of AI, speed is the ultimate form of efficiency. We didn't just decide to make a hot chip for the sake of it. We looked at the first principles of the world model. If we want an AI to understand the laws of gravity, the texture of a fabric, or the way light bounces off a window in a rainy street, we have to provide enough computational pressure to forge that understanding. You can't do that with a trickle of energy. You need a flood. But that flood must be controlled. This is why our engineering teams have become the world's leading experts in power delivery and thermal management. We had to rethink the entire motherboard. We had to rethink the power supply. We had to rethink the very air that moves through your computer case. When people ask if we went too far, I remind them of the early days of the automobile. People were terrified of the speeds. They thought the human body would disintegrate if it went faster than 30 miles per hour. But we didn't stop building faster cars. We built better brakes, better tires, and better roads. The 600-watt envelope is our better road. It is the infrastructure that allows the AI to travel at the speed of human thought. If we had stayed within the comfortable limits of the past, we would be stuck in a world of static images and scripted interactions. We would never reach the era of the omniverse, where every digital object behaves exactly like its physical counterpart. This brings me to the idea of resilience. At NVIDIA, we don't just build hardware, we build a culture that is resilient to the impossible. When we first introduced ray tracing, the industry laughed. They said it was a gimmick that used too much power and gave too little in return. We suffered through that skepticism for years, but we knew that the first principles of light were on our side. We knew that the only way to reach true photorealism was to simulate the actual physics of photons. We stayed the course. We took the pain of the early years, and today, ray tracing is the gold standard for every game and every professional visualization. The 600-watt challenge is no different. It is the price of entry for the next stage of our evolution. If you want a computer that can serve as your personal co-pilot, a computer that can write code, generate art, and help you understand the universe, you have to be willing to feed it. But we are also working tirelessly to make sure that for every watt we add, we are giving you back 1,000 times more in terms of capability. This is the NVIDIA multiplier. We are not just increasing the power, we are hyperscaling the value. Our company is a very flat organization because I want every engineer to feel the urgency of this mission. I want them to feel like we are still that tiny company at Denny's fighting for our lives. Because in a way, we are. The moment we become complacent, the moment we stop pushing the limits because they are too hard or too hot, is the moment we stop being NVIDIA. We have a saying, the more you buy, the more you save. It sounds like a joke, but it is a fundamental truth of accelerated computing. By investing in high-density, high-wattage units, you are actually saving the world's most precious resource, time. Think about the future we are constructing today. We are moving toward a world of physical AI, where the digital and physical worlds are completely synchronized. Imagine a doctor using a 50 series powered workstation to simulate a complex surgery on a digital twin of a patient before they ever pick up a scalpel. Imagine a scientist using that same power to model a new carbon capture material that could save our atmosphere. These are not gaming problems, these are humanity problems, and they require every bit of the 600 watts we can give them. When I look back at the moments where NVIDIA almost failed, I realize that those were the moments where we were most creative. Failure is the greatest teacher. It forces you to look at the first principles because everything else has let you down. The 600-watt problem forced us to be more creative than we have ever been. It forced us to invent the NVIDIA Grace CPUs and the NVLink interconnects that allow these massive chips to share data at impossible speeds. It forced us to become a systems company, not just a chip company. So, did we go too far? No. We went exactly where the future required us to go. We went to the edge of the map, and we started building a new world there. And I want you to join us. I want you to take this power and use it to build something that shocks the world. Use it to solve a problem that people have told you is impossible. Use it to create something beautiful. We are living in the most extraordinary time in human history. We are the first generation of humans who will work alongside an artificial intelligence that we created. We are the architects of the second industrial revolution. It is a heavy responsibility, but it is also a magnificent opportunity. To make the most of it, you have to be ready to run. You have to be ready to embrace the heat, the pressure, and the struggle. The future is not a destination. It is a direction. It is a choice we make every day to push beyond the limits of yesterday. At NVIDIA, we have made our choice. We have chosen to accelerate. We have chosen to innovate. We have chosen to be the engine of the AI era, and we are doing it with the same humility and the same urgency that we had 30 years ago. I want to thank you all for being part of this story. Whether you are a gamer, a developer, or a researcher, you are the reason we push these limits. You are the ones who turn our silicon into magic. We provide the tools, but you provide the soul of the machine. I can't wait to see what you build next. The logical conclusion of this journey is that the old definitions of efficiency and power are being replaced by a new metric, the speed of intelligence. If a machine can think faster, it can solve the world's problems faster. And that is the ultimate goal. We didn't go too far. We simply opened the door to a room that was previously locked. Now it's up to you to walk through it. Before I leave you today, I want to invite you to stay connected with us. If you believe in this vision of a more intelligent, more accelerated world, please subscribe to the channel and give this video a like. It helps us reach more people who want to be part of this revolution. And most importantly, if you have questions about the 600-watt problem, about the 50 series, or about where AI is taking us, please leave them in the comments below. I will be reading them, and I, Jensen, will respond to your questions quickly. I want to know what you're thinking. I want to know what challenges you're facing. We are at the threshold of a new age. The rules are being rewritten, the limits are being shattered, and the future is being generated in real time. It is a world of immense power and immense possibility, but it won't wait for the hesitant or the comfortable. Run, don't walk. I'll see you in the future.